Hi there, I'm Aditya, and welcome to this video where we'll dive into Content Security Policy (CSP), one of the best ways to secure your web applications. In this session, we'll first understand what CSP is and why it's important, and then we'll do a quick implementation to see it in action. So let's begin headfirst into CSP and uncover the why, what, and how. So, why CSP? Well, CSP is a tool that's used to enhance web security. So, in order to enhance web security, CSP is used. Then, what it is? Well, CSP is nothing but a tool that allows us to set the allowed sources, as in scripts, styles, images, and other resources that needs to be loaded by the browser. As in, if a source that's not already declared tries to load the content, it will be blocked. And lastly, how does it work and how can I implement it for my website? So that is pretty straightforward. All one needs to do is add CSP headers to the response. That is the response headers coming from your server. You just need to add CSP headers and declare the sources there. So we'll look into the implementation in detail and we'll actually implement it, but that is that. So let's take a moment to double down on the benefits of using CSP. Well, first of all, it enhances web security. Then it mitigates cross-site scripting risks and it builds defense against injection vulnerabilities. Let's paint down a scenario where cross-site scripting and injection vulnerabilities are causing harm to our website and then see how CSP can protect it. So in this example, we have a pretty standard web application service where our clients are sitting on the browser and interacting with our servers, which is connected to a data store. So in this scenario that we are going to walk through is called stored cross-site scripting, where someone can inject a script and push to our databases through some form that accepts text, and then hacker is basically exploiting the belief that everything that comes from the service is safe, that is from our service is safe. So we have a form that it accepts a text field, and this hacker is, instead of pushing in a text, is pushing a script element, and it's asking it to do certain things that are not good for our service, and we do not have proper checks for text, and there are misses from our side as well, and we accept it and we store it on our data store. Next time when we load that data on our website, what will happen is the script, instead of a text, runs it out, and because it's coming from our service, we consider it to be safe, and we are running a script that was not intentional and can cause all sorts of misery to our service. So that's the scenario, and content security policy can save us, as in we define the script source as self, but that itself is not going to protect us because script is still coming from our service itself. So we also have a CSP derivative of nonce, which is where we create random GUIDs. So that ensures that if the nonce value is not matching, which is not possible to match because it's 64-bit encoded and is generated uniquely for every HTTP request, and if that's not same, it will not allow the script to run, and more on it when we are actually implementing the nonce for our website. But that's the way we protect it, and that is the scenario how hackers can exploit us in the absence of CSP policies. Just one of the ways, by the way. Now, this is the official website of CSP. Link is in the description, and feel free to walk over it, and now it will make much more sense. We have all sorts of derivatives: style source, image source, connect source, font source, object source, which basically defines the source from which to expect these values. Report URI is another derivative that's used to report violations of CSP. When you block something that's violating CSP policy, we also report it. And then report to is where to report it. So we have all these derivatives, and the site provides proper definition of these derivatives and use case examples as well. And over here we have all the values, how to fill them in, what's their significance. Nonce is a value that's followed by hyphen random, and then random is uh, supposed to be 64-bit encoded string, and that's supposed to be generated. Best practices include that should be created or generated uniquely every HTTP request. And then we have some examples over here which you can walk over. So now let's quickly pace up to the implementation part where we will be implementing CSP in our response headers of our web application and see it live in action. The prerequisite is that, if you want to follow along, by the way, is that you have a Razor page driven .NET Core web application ready and running. In case you want to follow along and you don't have it running, you can follow the tutorial series on .NET Core on my channel to set up the web application that we have here. Alright, so I'm going to press F12 to open DevTools so that I can keep track of console and network tabs, and I'll quickly jump back to my Visual Studio and add the CSP headers to our responses using the .NET Core middleware's manipulation right after we are authorizing. So for our app, which is by itself very simple, the CSP policy we have defined is quite simple as well, which declares the default source, the script source, style source, and image source as self. On the browser, if I open the server response from that's coming from my local host at the moment, but will be coming from my server if I have deployed this code, I'll see that in the response headers, I'm able to see the content security policy declared as we did in the code. Back on Visual Studio, I'll just go into the index.cshtml, which is the basic view that's being loaded by default. And over there, I'll add a script to log on console hello world. And now if I go into my console on the browser, I'm seeing that there is a violation and hello world is not being logged on my browser. So I can see that it's coming from the log that we added on our CSHTML file. Now the violation is happening because we are running an inline script and we did not declared it in our CSP policy. So I'm just going to do that. I'm going to declare that we expect Unsafe-Inline to be enabled. That is, inline scripts can run. But this is not a good practice. In fact, it's a very risky practice because now we are giving the hackers the opportunity to inject vulnerabilities to a CSHTML, as in if they are able to inject scripts, we will run them anyhow. And that is a risk on our side, but I'm willing to take to just help me unblock at the moment. So now we are able to see the hello world being logged on our browser. That is that our inline script is running successfully. However, we are following not a good practice, as in we have introduced injection vulnerabilities and we need to fix that using nonce derivative. Let's do that. So we are going to follow now the best practice, that is to use nonce derivative whenever we are using Unsafe-Inline in a script source or style source. So I'm going to add nonce-123, but it's actually nonce-a random GUID, and there are guidelines to decide what that should be. It should be cryptographically safe and it should be 128 bits of character. You can study more about the guidelines on the official document. And right now for testing, we are just going to pass 123, and that is not a good practice, but for testing we are going to do that. And let's see what impact does it have on our website. And we see that our inline script is again blocked. So what's happening is it's a script that is not following the nonce derivative, and that is why it's been blocked. Let's add that nonce value to our script to ensure that it runs properly. So we need to just add nonce equal to the value that we added in our CSP headers. And mind you, this will be unique for every HTTP request that's being generated. So right now it's constant. That is again not a safe practice, but once we do that and the nonce value on the script and the CSP header matches, the inline script is allowed. And for each HTTP request, this nonce value will be generated, which is cryptographically secure and follows the guidelines, is stored in a variable, and that's picked from the inline script. And only when these two match, which is being generated continuously for every HTTP request, the inline script is allowed. And that makes it super secure, as in even if you are able to inject scripts to a service, you will never be able to match the dynamically being created nonce random unique values, and thus your script will be blocked. And that's the power of CSP, guys. Thank you for watching this video. I hope you enjoyed it and you found it helpful. If you did, do drop a thumbs up. That lets me know that you had a good time. And do subscribe my channel for more such contents. Have a good day.